we restart. So I think if that's all right and everyone's happy with that, I'll hand over to you, Tim.
Yeah, thanks, Jill, for introducing me. Welcome to everybody for this, what we call in our institute a lunch seminar, more or less. Yeah, today I want to talk about some coastal issues far away from the place where I'm sitting and Hainan, China, because that's the mission of our institute is to do research on tropical coasts and exclusively on tropical coasts. And that's why always when I want to go to the field, I have to travel a long way, which is impossible right now, but at least I can report on the work that we did there. And that is just referring to or just showing to how coastal development can impair the functioning, the services, and also the connectivity of coastal ecosystems at the example of Hainan, an island in the South China Sea. And we don't only want to look at the problems it is causing, but also on the way forward and what can we do and look for solutions. This is, you see a number of authors here. It's a kind of collaboration, but what I'm talking about is the result of a long-term collaboration of a Sino-German collaboration, marine science and technology, with a couple of research organizations in both countries in 3 projects that we had from 2006 to 2011. It was the research project Lancet, followed by Ecolog from 2015 and 2018. And now from 2017 on, we have the project TICAS, which is not a research project, but is designed to establish a science-society interface with the most important task to make our research results more useful, more applicable for society. So, I mean, the relevance of the coastal zone should be quite obvious for all of you who are working with coasts, but I think this is quite a nice illustration, though quite old, still the best one can find, showing you where people live. You see that the darker the green shading here is, the more people live along the coast. And then the marked shoreline, you can almost read like a traffic light. Red means most altered coast, orange moderately altered, and blue is least altered. And if you take a look at this red circle there, you see in particular here in China or Southeast Asia in general, the shorelines are heavily altered because there's such a lot of people living close to the coast economically, depending on the resources. And you also see this huge number of large cities in China. So, and down there we have the island of Hainan. So it's of particular importance for us at the ZNT also, because there we also in the tropical zone, we find all those fragile but ecologically and economically also important ecosystems, coral reefs, mangrove forests, seagrass meadows, and you see in the area in the Southeast Asia, Western Pacific region, we also have the highest diversity. If you combine these 2 maps, you can simply say the result is that, of course, the integrity and the economic potential of these coastal zones are strongly endangered. And we have one example. And it's not only important to look at individual ecosystems there, because we find the whole suite of them in this land-ocean transition. And we should not look at them isolated because they are all connected. You can see this here on this graph, showing you that there's a strong connectivity and all these ecosystems nourish each other, but also protect each other. So it's always important to have a look at them at the whole association of these ecosystems. And we did this, and we still do it in Hainan. Why is that important? It's the important thing is for China is this is the largest special economic zone that China has, and it's existing for a long time. It was established in 1988, and at present, the most important contributions to the gross domestic product are tourism, agriculture, industry, aquaculture. Not that much fisheries anymore. And tourism is the most strongly expanding sector. And what Hainan is also called the Hawaii of China. You see there's a beautiful beach. I mean, I could show you other not so beautiful beaches. And you see the people are really wearing Hawaii dresses. So it's an important tourist destination, mainly for Chinese. They also call it an international tourist destination, but I think it's mostly Russians that are, besides Chinese, coming to Hainan. Yeah, this is how it looked like. If you look at the sketch, in the middle of the last century, before we had this great acceleration in the Anthropocene, there we had this beautiful coastline there in Hainan, in a tropical region, with abundant coral reefs, seagrass meadows, flourishing mangroves, almost no aquaculture, and small rivers entering the sea, and artisanal fisheries could sustain the livelihoods of the local population. But then development started. At present, Hainan has about 10 million inhabitants. It's not so densely populated. I think it's 250 to 300 inhabitants per square kilometer. Nevertheless, there was and is a strong coastal development, and this population increase and coastal development simply means you get problems for the ecosystems, the resource exploitation, and the most important challenges in that sense for the ecosystem functioning are aquaculture, agriculture, sewage input, and also overfishing. So, and we now looked at some of these problems. Of course, aquaculture was extremely expanding there in the past decades, and this was also part of the project where my working group was working on most intensive. So that's why we'll put a focus on this. And we were looking at the seagrass response to this aquaculture effluence. And if you take a look at the map here, you see we were working in the northeastern area of Hainan, and in pink you see all the aquaculture ponds here. In many cases, or in most of the area, this pink was just replacing the dark green, the mangrove forests. So a major part of it was mangrove forest before it. We have some remnants here, and the larger part of mangroves here in this Barmen Bay. And then we have seagrass meadows in front of the coastal zone here, and bordering coral reefs. And we were looking at 3 of these areas: Yilin, Changchi, and also Chinge, with Yilin having the least input or least exposure to aquaculture ponds, Changchi having the largest. Changchi having the largest exposure to aquaculture ponds, and Chinge in yellow with some medium input. And you could easily see it if you just look at Google Maps. You see there's a huge spread of aquaculture ponds almost everywhere in the coastal zone. And in the bottom, you see there's in many cases, there's a small mangrove rim left, just 25 to 50 meters maybe. But behind that, you have the aquaculture ponds, and then there are these small tidal channels through which the untreated effluents are directly washed out into the coastal zone. So by satellite image analysis, we were able to follow this history of development, and also to quantify the mangrove forest loss and the extension of aquaculture ponds. And you see there's almost reverse curves, with a large decrease of mangrove forest to about 1,000 hectares in the area, from 72% decrease over 5 decades, and at the same time an increase in the aquaculture pond area, with the present day extent of aquaculture pond being reached almost around the turn of the millennium. So in the year 2000, we had almost the present extent of aquaculture pond area, and that also means from that time on we had this input of untreated wastewaters into the back reef areas. And this is how you could see it a couple of years ago. If you're just standing on the beach, you see these small inlets where the effluents are just running out into the back reef areas. And what we found there when we measured the nitrogen concentration, the dissolved nitrogen concentration in the water, it is about 20 to 50 times higher as in unaffected coastal waters. And we also took a closer look at the composition of this nitrogen, and first looking at the different species that you can find. So the majority of this is ammonium. Just only 1/3 of it is being nitrate. If it comes from agriculture, you would expect a very large amount of nitrate. But here in this case, the vast majority of the effluents was ammonium. And we also measured the stable nitrogen isotope composition in order to trace the origin of this nitrogen further on in the coastal waters. And we see there's also a large difference in the delta 15N of the nitrate in the ammonium. So for nitrate, it's the delta 15N is 7 per mil, and for ammonium, delta 15N is 18 per mil. So there's a large difference in the isotopic composition, giving us an idea on the sources. So if we use that and then go out into the waters and look at the seagrasses, one of the measurements we did is, of course, the nitrogen content and the delta 15N of the seagrasses. Here we have the delta 15N in leaves of Thalassia hempricci, which is the most dominant and also largest of the 7 or 8 species that we found there. And we see a transect perpendicular to the coast in the area of Chingue with a medium exposure to aquaculture ponds, and we see in shortest distance to these ponds we have the maximum delta 15N value of 8 to 9, and then with a decrease towards the reef. So in 1,000 meter distance it's already decreased to 5.5 or 6. So we have this gradient, and we have this very high delta 15N, and so it's quite evident that there's this large input of ammonium from the aquaculture effluents is being taken up by the seagrasses. And of course, closest to the source, there's the largest delta 15N, so the largest signal of uptake of anthropogenic nutrients in this case. And the more we come to the reef or towards the open ocean, we see there's more admixture of seawater with less heavy nitrogen in it. So, but what does it mean in the global context? Is our high really high, or is it just a local phenomenon? So we put it in context with other data that we have, and we see in gray all the dots from other areas in the world, and we have this very high values also in Kenya, as we can see there. But if you look to the right, then we have our data from Hainan on the left hand side from 2008 and 2009 when we first went there, and you see still they are much higher than most of the other values around the globe. And if we look at the data taken in 2017, we see even an increase, in particular in the area of Changchi, where we had the highest exposure to aquaculture pond effluents. And also this one value there from Kenya, this extremely high value is from a sewage outlet close to a hotel, so where the seagrass meadow is still there left close to this hotel, but will probably disappear soon because of the high load. But it also tells us clearly the proximity of the anthropogenic source of the nitrogen in that case. So on a global scale, we see very high values, which also points to obviously probably very high impact of these anthropogenic nutrients. So we see this elevated delta 15N of the anthropogenic origin in the seagrass tissue, which is originating from this aquaculture effluent, mainly ammonium, and with a very high delta 15N. So then we had a very large data set collected from 2 periods in 2 years, and with very sophisticated Bayesian statistics. A PhD student of mine was able to to find distinct groups of seagrasses, and we found a statistically significant relationship between seagrass biomass and the dissolved inorganic nitrogen in the water. And so we could identify 3 groups, with the first group with a fairly high biomass, roughly 200 grams dry weight per square meter, doing very well when it was exposed to a dissolved inorganic nitrogen concentration of less than 0.9 micromoles. Then there's a second group with already much less biomass. I think that was below 50 grams per dry weight per square meter, but still existing, and in the range of 0.9 to 8 micromoles DIN. And then if we look at the third group with very, very low biomass, so at an exposure to more than 8 micromoles of DIN, there's almost no seagrass left. What is important to say in this context is that we observed in these three areas an 87% seagrass loss between 2008 and 9 and 2017. And we could identify really, in a way, a kind of seagrass survival threshold with this data set of these 8 micromoles DAN. That's important to say. And it's important to say it's a long-term threshold, because if you would say 8 micromoles is not that much. If you expose seagrasses to 8, 10, 20, 30 micromoles on the short term, well, they would flourish. It would be great, but not in the long term. And of course, mostly if these kind of assessments are done, there are no long-term data existing. That's why it is so important that we have this data set and that we could identify this threshold, because in a way it also shows us that there's a delayed response of the organisms, in this case of the seagrass plants, to this exposure to nutrients. And it's not only the DIN. The DIN is our proxy from the statistics standing for eutrophic conditions, which also means not only this long-term exposure to these 8 micromoles of DIN, but what comes with it is phytoplankton, so microalgae growth, a higher turbidity, more shading, less light that is available for the seagrasses. All this taken together, but our proxy, or statistically significant proxy, is the DIN. Yeah, and then if we take these ranges now and look at the distribution of our data in the upper panel, you see our data from Hainan, and you see there's some kind of individual variations, but most of the flourishing seagrasses fall into this area below 0.9 micromoles of DIN, then the vast majority in the other range, and then there's these only little bit left when we have higher concentrations of DIN on the long term. And on the lower panel, we took the same thresholds that we had developed from our area and looked and just plotted the data from other regions, for which, of course, there's no long-term data existing, so it's mostly short-term. But it also tells us that in all these areas, they are also in the critical zones, at least in this area, yeah, they're in this medium range, and in some cases they are also in this highly endangered range. So we could say they will probably get into trouble in the coming years. So that's why this was an important finding with regard to the seagrasses. And of course, we could also trace this anthropogenic nitrogen also in other trophic levels in the food web, and we also found it in the sediments. So we had several hundreds of measurements from other trophic levels there. Here we see we had micro and macro algae. Of course, we had mangroves as a potential source of the gastropods and bivalves, crustaceans, and also fish. And in all cases, the levels were high. You remember, we are starting with a very high level or very high delta 15N, and that means, and also for the further trophic levels, we also have very high values of the delta 15N in all these cases, showing us that this anthropogenic nitrogen is everywhere in the food web. And not only in the food web, we also find it in the sediments. We took a couple of sediment cores from this Barman Bay I showed you, and this one core from the center of the lagoon, which is also receiving a lot of aquaculture effluent, which we could also date. So we have age dates here, and you see this here. We're just looking at the delta 15N, where we see there's an increase roughly from 1990 on. And if you remember that I said that the maximum pond area was reached roughly around 2000, where we still had another increase. We could also simply see this signal also in the sediment. There's a lot of primary production, of course, of microalgae, also fueled by this delta 15N and then sinking to the bottom, and so transferring the signal into the sediment. So we see this high delta 15N originating from the aquaculture effluents everywhere in the food web and also in the sediment. And we have seen, of course, the seagrass loss. This is an original photograph. We did not only measure it, we could see it. That's how it looks like in an area which is exposed to these 8 micromoles of DIN. There's a really murky water, and you see there's also lots of epiphytes, strong epiphyte overgrowth on the seagrasses, and these are the seagrasses which are probably dying soon. And as we mentioned, Esther, when Esther was traveling there, and we told her, do all the measurements, do the same thing we did a couple of years ago, and she wanted to do that, went there, phoned us and said, in 2 of the area there's no more seagrass left. And then we said at home, oh well, we consider this a good result. Of course, it's not good for the seagrass, but this is what we expected when we did the first measurements, and now we see it. And on the other hand, this also enabled us to come up with this threshold. But this is how it looks like. And of course, it's not only the seagrass that is affected. If you take coral reefs, there are also from this northeastern coast, 5 spots. You see the live cover there in many areas is very low, mostly 5 to 10% or even less. And you see there's one or the other fish, but almost nothing left. So the reasons for this are not only eutrophication from the aquaculture effluents, but of course also overfishing, bleaching events, of course, also contributing to which are impairing the coral reefs. But of course, this aquaculture effluent exposure is also one of the reasons contributing to that. And these are just recent numbers from our colleagues in Hainan, just showing you the decline of coral, of live coral cover over the past 15 years almost, and showing us that not only in the eastern area where we measured, we have a decline in coral cover, but also in the west and in the south. So it's a common feature all around Hainan. Yeah, and so if we look at that now and see what has happened there, and it's again showing how this coastal area now looks. The gray shaded areas show you that there's a lot of loss. So from the original mangrove cover, there's more than 2/3 lost already, or 3/4. A huge lot of the seagrasses is lost, also shaded in gray here, and there's also a lot of the coral tissue lost. We have this very strong input from aquaculture. Of course, there's also municipal sewage, there's shipping traffic, and there are other reasons. So for example, we also found organotins from shipping paint taken up by organisms. There's a lot of antibiotics and antibiotic resistance genes, pathogens released from aquaculture. Then there's pH contamination, and you can see it particularly in coral tissue. So there's a lot of effects that we see, and a lot of the organisms are dead. There's low benthos diversity. There are also greenhouse gas emissions from the aquaculture ponds, of course. How much and the composition of the emissions is very much depending on the aquaculture operation mode. And yeah, we've seen this drastic loss in seagrass density and also of diversity, I should have mentioned. Yeah, if we sum this up, we see that there's a large loss of mangrove forests, of the seagrass beds, of the coral reefs. Of course, the ecosystems are almost gone. The connectivity is disrupted. That means a lot of ecosystem services are lost. For example, water quality maintenance, carbon storage, but also nurseries or coastal protections. Subsistence fisheries is almost not existing anymore. And of course, in the end, even the tourism potential, of course, is also strongly impaired, because it's the beauty of these ecosystems that is the major backbone of this tourism. So, but it's not only we who have realized this, but of course, everybody in Hainan has realized that, and that's why a lot is done already to improve this. Also by us, we have a collaborative project with our partners in Hainan to do something towards a more sustainable use of the coastal zone. And in this project TICAS, we have established a science-society interface. And our major tasks in it are to raise awareness among all stakeholders, not only about politicians, but also all kind of decision makers, the public, the resource users, etc., and also NGOs, etc. And of course, we strongly contribute to capacity building, again, for all stakeholder groups. We try to use our results also to help them with decision support, and we also try to use that or simply implement ecosystem restoration. And I've just listed a few of examples here. Just starting here, we initiated a citizen science project for seagrass monitoring, and this is my colleague Jialin Zhang. She's mainly doing the work, so she's responsible for implementing all this. She's a Chinese, quite obvious, but she's living in Europe and has done part of her education in Europe, so she's very well established in both cultures and is therefore the right person for the communication that we need in that case. And so we initiated the Citizen Sciences project on seagrass monitoring, and it's still existing. We started this more than 3 years ago, and it's still there. So and it's working on its own, and that's in a way a kind of success for us. Then we went to schools. Experiments in schools were done. We had aquaculture, farmer training courses. We did stakeholder workshops, bringing everybody on the table. We gave public talks on there, and Jalin also gave radio interviews. We just last year published a policy brief, and there's also as a kind of as a spin-off of our project. There's a seagrass restoration project now going on, done by our local Chinese partners. Yeah, and some other success that we see, of course, we do something, but we also want to know, in a way, try to be able to assess, to evaluate what we did. And I think we have quite some nice examples. As I told you, we have the seagrass conservation project that goes on, and there's another one that was just applied for last year, mainly by local people, by local NGOs, but supported by us. And then now finally funded by the Chilan Foundation, launched in January last year in order to protect the seagrass ecosystems by promoting knowledge exchange and collaboration between research organizations and NGOs. And of course, and also to warrant that this seagrass citizen science monitoring is continued, and also to develop further seagrass education programs and toolboxes. And on the right-hand side, we also have a fairly recent example, which I also find a very nice example. One of the NGOs that we're working with is called the Squirrel School, is also going to schools. And here, this context, the seagrass education team came together and gave several lectures on seagrass and other important coastal ecosystems for more than 100 students from elementary school. And what is quite nice to see, and maybe the best evidence of success, is this drawing from one of the pupils. And you see they can even draw the seagrasses with the roots and the rhizomes. And we have other animals, crabs, turtles, fish there. And so obviously they have learned something, and they're able to express this when drawing it. So that's very nice evidence of the success of these measures that we have. And the seagrass education team is, of course, doing more. They have compiled an education handbook and other materials with the aim to provide educators with information on the basic knowledge of seagrass and other relevant education activities. And we ourselves also produced fact sheets, etc., that can be used by all stakeholders. Yeah, and what is quite interesting also, if we look at the policy level, this is from a recent paper that came out this year. It was quite interesting. I heard a talk in a conference in China and earlier this year, where this person who has just published this was also looking at the aquaculture pond area, in that case of the whole island, and also discussed how this may have been affected by political decisions. And here you see the timeline, and I'm just plotting here, not to scale, but the aquaculture area development. So there was a moderate increase until 1995, and then there was this policy of accelerated development of aquaculture in the area. And that's why we had a strong increase until 2005. But then people also learned this environmental problems started, and it was also a problem to get the produced aquaculture project, the aquaculture products sold. So there were quality and safety issues. That's why there was another policy release on the national level, in a kind of deceleration of this aquaculture increase, and which was also shown then in the aquaculture area that was only moderately increasing until 2015, from which on it was then decreasing, because there were other decisions made then more on the local, on the regional level. So from the Hainan government, Hainan as a province, in 2009 with suggestions on promoting the construction and development of Hainan's international tourism island, but also putting a strong focus on sustainable development, just realizing that there are problems. And this was enforced even in 2013, going on with new regulations on the protection and development of coastal zones, now also including ecological restoration, being aware that a large part of the mangroves, the seagrasses, and the coral reefs are lost or at least impaired. And this is also, I think, where we come in with our activities, because the Hainan coordinator, the scientific coordinator of our collaboration project, is also an advisor to the provincial government. And we had, as from the first phase of our research, we also had a paper in which we gave recommendations for decision makers, which he also transferred into this government level. And now this increased the awareness. And now with the second phase of research, we also had even a better, well, let's say, connection also to policy. And we also see some of our results being taken up by decision makers, without being able to do it point by point. Yeah? That's something I have to admit in this context. Yeah, and it's also important because it does something with us as scientists that we learn, because our roles are changing a bit. Or I call it here, it's expanding the scientist's role. So we do not only do the research, but we also have to communicate in different ways and in a way to make our research results even more useful and applicable for society, because mostly in a research organization, we also paid by the taxpayers. And this is just something new that was just published by POGO, the Partnership for Observation of the Global Ocean. They were looking for case studies, just showing this kind of this connection between science and society, and they wanted to have real examples, and that's why we said, hey, we have one example from Hainan, and it was just published this week. And you can find it on the POGO website, where it is published, just showing the whole story from identifying the problem to our link to science and society and how to come up with solutions. And of course, that is something that is still in its infancy and to a large extent still depending on personal engagement, on personal involvement, let's say on the environmentalist heart in us as scientists. But of course, it is something that needs to be institutionalized. And that's also part of the work that we're doing in our project. We are not only working on the project level in the area of Hainan, but we're also trying to contribute to institutionalize it, to conceptualizing it. And we are just working on a paper. Jalin Tsang is now currently preparing it. Is the lead author of that. And just showing it what we do. The first thing you usually start with is some kind of knowledge transfer. You throw out your scientific results on society and say, well, do with it what you want without explaining. Of course, then you need more. The least is you have to translate in a way that people understand, that stakeholders understand and become aware and accept such a position, for example, just to be able just to digest what you did. And then, of course, it's also important for us as scientists not to stay there on our own, but also to get at some kind of exchange with society, ask stakeholders, what do you think is important? What did you see? What are the project problems that you see? And ideally, I don't know if this is really possible, but it's something that is quite popular now, the idea at least, and we're also trying to work on is then knowledge co-production. Use indigenous knowledge, etc., or simply use for example, citizen science in a way to contribute to co-production. And the lower part just shows you what we are doing, or what Jalin always calls the transfer from the normal science model to the engaged science model. So in a way that we have various steps in between to involve the stakeholders, yeah, to do a context analysis and to identify the stakeholders in your particular case, and then to have a kind of framework for this collaboration, network building, joint agenda and goal setting, and then also maybe stakeholder prioritizations. Then some intermediary work implementation. There are several levels of interaction that you can have, just on the informing stage, on the consulting stage, or even on the engaging, collaborating stage. And this is something that is also context and stakeholder dependent. And in the end, of course, evaluation. That's while the whole thing is still in its infancy, it's very difficult to get some kind of evaluation. But we're doing it. We're also starting to do it. And I showed you some examples where we can say, yeah, that's quite some success. So that's how we try to transfer from a normal to an engaged science model. And that's also what we're planning for a hopefully soon to come new project with China. So to sum this up, we have seen that decades of coastal development strongly impaired and impairs the functions, services, and connectivity of Hainan's coastal ecosystems, which are also the major backbone of the economy. The conversion of mangroves to aquaculture ponds means you're replacing a sink for land-derived nitrogen with a source. And it's not only a sink for nitrogen, it's also other substances that are filtered out by mangroves. So we've seen the coastal waters are eutrophied and polluted. There are also other pollutants that are released, which I could not just talk more about in this short time. The mangroves and the seagrasses are lost to a large extent, and the coral reefs are also lost to a large extent. At least they're in very bad shape. We've seen the coastal ecosystem connectivity is disrupted and the ecosystem service supply diminished. And that's why we thought and then also did implement a science-society interface. We have established it in the meantime, and I think it's doing very well in order to protect these coastal ecosystems. And we also see that there are real restoration activities also resulting from our science-society interface, which is a very rewarding experience, I have to say. So if you're interested to learn more, we have a lot of publications on this done. From the first phase, we've done a special issue of continental shelf research, and we have a more recent publications from the past years, and also our policy brief, which just gives recommendation for decision makers. And of course, it's still running. So if you want to be up to date with all activities, visit our website. And with this, I want to close and thank you for your attention.
Thank you very much, Tim. That was really good. I think we can all do our little hands, can't we? We can do our reactions and give you a round of applause, sort of virtually.
Thank you.
Hopefully everyone could now pop their cameras on if they would like, and we'll hopefully have some questions. I just want, if I may just start with a question, because I'm here first. And I just wondered, one of the things was I noticed, I mean, it's really interesting talk and really interesting how you've connected right from a problem which started not that long ago, which is sort of that was quite shocking that it's sort of like in the 50s and the 60s that this started, and it doesn't seem that long, but it's obviously there's a lot of change. When you were looking at the stakeholder groups, you didn't seem to mention the people doing the aquaculture and sort of managing the aquaculture in a different way. Have you engaged with them a lot, or is that very difficult to engage with the people involved in aquaculture?
No, I think it was quite okay. There was in the first phase, there was a kind of survey, not really in a kind of a thesis, but a student doing some surveys, and we also approached some aquaculture farmers. And we did it in a more sophisticated manner in the past years when Jalin was involved. But individuals, and in one case, I was even with people when we were asking them, they said, of course, they would have liked to have some training, then they could possibly do better. So what we saw 15 years ago were well, very simple ponds. And I had the impression it was mostly individuals doing it, not really companies. And when we returned 10 years later, I saw large technical improvements of the ponds. They were larger and looked more professional. And they were also smart. Instead of just having these small channels to the beach, they had pipes and hoses, just pumping water into the ponds, but also pumping water out of the ponds so that you don't see it anymore. And just using this dilution function. Yeah, so it dilutes in the ocean, and if we don't see it anymore, it's not there, the problem. So, but as I mentioned, there was aquaculture farmer training, so there were several training courses in the past years, so that they are looking for it, and there's even policy is now taking this up, and they are reducing aquaculture pond area. So there's a lot of activity going on.
Yeah,
we are just a small part of it.
Yeah. Okay. Thank you very much. So, do we have questions? Eric Wolanski, he has a question which he's just put in chat. So, do you want to ask it yourself, Eric?
How can you? Okay.
No. Okay. I can ask Eric's question. How can you restore the ecosystem if the pollution source that killed it in the first place is not removed? This requires government actions. Are there such actions?
Yes, as I just mentioned, policy is changing, so they are now reducing aquaculture pond area. They had already professionalized it a bit, at least as I could see it. As I mentioned, just putting out the pipes, I don't know, 200 meters out in the ocean is not really getting rid of the problem, but I think they will also improve the management of the ponds, which includes just having a more efficient feed management, for example. I've seen this also in other countries. Once they know how much they need to feed, they could save money, and of course it saves the environment to some extent, and they only need to know. And this is what is done in the training courses, which were not done by us, but by our partners, but also the scientific partners.
Great, thank you. Mike, can you ask your question?
Yeah, thanks, Gillian, and thanks, Tim, for a great talk. Of course, I knew some of the work you're doing, but I didn't know all the details. Just taking your last point there, and we see this all over with as you know, with coasts and marine areas. We start thinking about it's an either or something, when actually, in order to get the to satisfy the people there, we need both. We need both the aquaculture and we need the mangroves and seagrass beds. I mean, I remember a while ago, just as some of you do, where there was this desire to use reed beds for treating waste and trying to look for better ways of treating material. But the big question is, how do we get both of those? You started saying it just now, but with better aquaculture, but it's getting both of those. And then one of the other things we also have to worry about is, by losing the mangroves, we've lost that resilience. You know, if there was a tsunami, heaven forbid, if there was a tsunami in that area, then there's nothing to stop it. It would just go inland. But so it's how do we get both of these?
Yeah, I think it's you need sustainable development. Yeah. Nicely used term, but I think the problem, what we saw here with the seagrasses, for example, is you look at 8 micromoles of DAN and say that's not much, and you don't see a problem. And it takes obviously roughly 2 decades of exposure to such a concentration, which you would never call harmless if you knew not that. That means there's 20 years of delay of any action because you don't see anything. And we usually start acting only when we see something bad happening, and not when we start measuring it. I had an interesting discussion with a former PhD student who was looking at such an eutrophication impact in the Indonesian islands on the Spermonde archipelago of Sulawesi, which is 60-70 kilometers off a large city in a small river. And they were always looking for eutrophication gradients based on this river source. And there was nothing close to the island. But because there was no physical connection, the hydrodynamics were just in a different direction. So all this water from the river was transported somewhere else, but not to these coral islands. And then I told him, try to measure what happens on the island. Because it's amazing to see on Google Maps, it's full with inhabitants and it's untreated sewage and it's all released in the waters. And he started measuring it and compared it to an uninhabited island. He found nitrate and phosphate levels below 1 micromole or so. And also chlorophyll 1 microgram, 2-3 micrograms per liter, really very low, but statistically significant more than on the uninhabited island. And there was a change in the microbiome of the sediments. So this is in a way an early warning system of what happens. You don't see anything, it looks nice. Every manager would say, if you look in eutrophication gradients, no problem. But as a scientist, with the scientific tools, you see the problem starting, and the consequence will be there maybe in 20 years. Or if you take just this dilution, the oceanographers after 30 years tell you the oxygen minimum zones in the global ocean have increased. That's the cumulative result of it. That's the problem of these timescales of realizing a problem. And I think now, in many cases, we know about these problems, and only now we start acting. And there's a lot of conservation and restoration activities going on now. But in many cases, because of a 10, 20 years delayed response of the ecosystem to the impact.
Thank you. Can I ask Arya from the University of Kerala? I think you've got a question. You've got your hand up.
Hello.
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 Oh.
I am Arya, research scholar from Department of Environmental Science, University of Kerala. Nice presentation, sir. And I am very much interested in this concept of science society interface. As you mentioned that 72% of the mangrove is replaced by the aquaculture pond. What extent we can restore it? Can we restore it completely? It will be a big challenge to the existing aquaculture pond. How, what extent this science society interface can help?
You want to know how they can be restored, the mangroves, yeah?
Yes, yes.
Yeah, I think it is possible, but it is difficult. You have the problem that there's always a lot of organic matter in the ponds, and depending on how often and how they are cleaned, a lot of it is remaining there. You get anoxic sediments, and then during cleaning cycles, and then you have a lot of sulfides in the sediment. And during cleaning cycles, this may be exposed to oxygen. Then it's all it's all oxidated and oxidized, and then you have a release of all this acid, sulfuric acid. So you have a soil acidification to a large extent in many areas, and it takes probably quite some time to remove this, to remove all this acidified soil, or cleaning cycles of just, I would just say you cannot use it for a long time, at least if you want to convert it, for example, to aquaculture, or if you want to restore it. And of course, what is very important, most important for mangrove restoration or conservation is not only just planting mangroves, but to have the environmental setting in a way reconstructed. So the hydrodynamics, that's very important. If you don't have the right hydrodynamic conditions, planting will not help too much. And it's also then not just monocultural planting, but you should have a community of plants, a kind of natural community to some extent, in order to get mangroves restored. But of course, that also takes time, but it's not impossible, I would say. And there's also hope, because you also see there's the loss rates of mangroves are strongly decreasing, or were strongly decreasing in the past decade. And there's also some area gains in other parts of the world. So it's we should be optimistic, but there's still a lot more way to go.
Okay, sir, let's hope. Thank you.
You're welcome.
Thank you very much. And I think probably this will be our last question, because I think we're running up towards time. And this is from Anita Franco.
Yes, thank you, Tim, for the very interesting presentation. And my question actually it's been already partly answered from with Arya's question, because I was wondering, you mentioned that today a policy, some of the action that are being undertaken is to reduce the aquaculture ponds. So it is, first of all, is it an actual reduction, as in they are closing ponds, or is just a limitation to further expansion? And if they are closing ponds, whether there are plans to reconvert them restore them into the original mangroves, knowing that, as you just say, it's not something you do overnight. It needs, it might be difficult, but whether there are plans to do this in the future.
Yes, I think so. I mean, I have no direct contact with the politicians there, but I know at least our long-term partner there, who's also the advisor to the provincial government. He was always very interested in pushing this forward. And yes, with the measures they took in 2009 and 2013 on the provincial scale, they first included the term sustainable development and then also ecological restoration, which really means also restoration of mangroves and seagrass meadows. And I've shown this one example of seagrass restoration. You also saw that they have a small grid that they place there, because also for the seagrasses, it's important that the hydrodynamic conditions are suitable for having the seagrass there and not losing everything again. So they are doing it. They're having a research project in our partner institute, which is a research organization or a provincial government research organization. So they're in between. They're not just a university, and they are conducting research on the seagrass together with us, but they are also conducting this seagrass restoration project, just looking at how can we do it. And then the next step would be to implement this on a larger scale.
Okay.
Thank you, Tim.
The final question I've just got here is Sabine Apitz has just asked where you're planning on publishing this.
Yeah, I mentioned we have published a lot, and if you look at our website or my personal website, you find the links to those, or send me an email. I can send you the papers. And what else?
She was referring to the Science Society link.
Yeah. So as I mentioned, one manuscript is in preparation, and we are also part of another study. An Australian PhD student was just looking for bright spots in knowledge exchange success. So he identified 25 projects which are doing this, and is now looking at it, at the motivations, etc., and also at the success. This is now a multi-author manuscript that is going in its final phase before submission. So and our own paper will also be submitted soon. So I would say manuscripts will be submitted in January too, and hopefully available in half a year or so. I don't know what will happen with that, but we are publishing it, yes.
Okay, that's great. Well, I think we'll have to leave it there because we're just 3 minutes to 2 o'clock. So I just would say thank you very much, Tim, for a really interesting talk to a very international audience, as a super international audience that we've got here.